Brought to you today by SAICE Information Technology Division. My name is Peter Webb. I'm current chairperson of the IT division. So before we begin, I'd like to give you a very quick overview of the SAICE IT division. So the focus of the division is to add value to educating our industry on new technologies, new developments, for example, Fourth Industrial Revolution, artificial intelligence, BIM, cloud collaboration, Internet of Things, just to name a few, both from a hardware, software, and human perspective, and to reimagine our workflows through 2023 and beyond. So in line with our objectives, the division seeks to expose new technologies that may become useful to civil engineering profession, particularly as traditional boundaries between engineering disciplines are becoming increasingly fluid. We aim to serve our members by providing relevant content timelessly, always taking into account their needs, and of course to attract more professionals into the industry, particularly by encouraging young and older professionals to become aware of new technologies whilst maintaining regard to their social, environmental, and economic impacts. So before we start, a bit of housekeeping. If you have any questions, we'll be handling those at the end of the presentations. And you can put your questions into the chat box. With regard to extra CPD points, CPD has been applied for this webinar. So I would now like to go ahead and introduce our speakers for this webinar. So we have 3 speakers today from right across the globe. So we'd like to introduce, first of all, Katie Bevan, who's the Program Delivery Manager at United Utilities in the United Kingdom. So Katie is a water industry professional with 9 years of experience at United Utilities, one of the largest listed water companies in the UK. Strong background in wastewater network operations, with current role as Program Delivery Manager, overseeing the delivery of several key programs of routine maintenance work across the region, including sewer cleaning and associated CCTV survey works, non-powered asset inspections, wet well cleansing and maintenance of customer flood mitigation, key experience in efficiency challenges, and the support of onboarding new technologies into the business. So welcome, Katie. Next, we have Alekia. Alekia Ramarajan is an experienced data scientist with expertise in AI, deep learning, machine learning, and computer vision. She has a background in electrical and software engineering, allowing her to seamlessly integrate cutting-edge AI and machine learning models into conventional software engineering practices. Passionate about enabling businesses to acquire invaluable insights, enhance decision-making, streamline processes, and achieve transformative outcomes using AI and advanced analytics. And then we have Mark Lee, who's a civil engineer from Vapor. So Mark has spent more than a decade as an engineer managing the asset life cycle of pipes. He's been involved in design and construction through to condition assessment and decommissioning, including all that occurs between. He made the move from a public utility to Vapor after seeing the industry's need for improved modern solutions to pipe condition assessment and the associated management of data. So Mark is passionate about improving business efficiency and utilizing the data to drive smart decisions. So welcome everyone, and what I'm sure is going to be a most interesting presentation from the 3 of you. I'd now like to hand over to Mark Lee, if you would like to start your presentation, Mark. Thank you.
Thanks very much for the invitation. That's the introduction there, Peter. So good afternoon, everyone. Thanks for the invitation today to have a chat about how artificial intelligence and the automation of tasks is being used in the engineering sector. It seems as though AI has been one of the hottest topics over the last 12 months, with ingenious use cases, as well as robust discussions on the speed and the direction that AI is being developed and adopted. So the next hour or so should be a good opportunity for us to take a look at what the impacts and benefits of this advancement have been closer to our own work environments. To keep the discussion varied and engaging, what we've done is we've split the webinar into 3 different parts, starting with a look at what's happening in this space in parts of the utilities industry. We then have a data scientist delve further into AI to provide some background and explanations on the inner workings of various types of artificial intelligence. And then the third presentation is from Katie Bevan, who works at United Utilities in the UK. And Katie will run through a case study describing the rollout of some AI solutions into their business workflow. So quick intro from my side. My name's Mark Lee. I'm based just north of Sydney in Australia and work for Vapor, which is an AI software company in the engineering sector. It's actually been 20 years since my last visit to South Africa, and I thoroughly enjoyed the trip. So I was enthusiastic when Peter reached out to ask if I was interested in preparing a webinar session for the South African Institute of Civil Engineering. I started as an investigations engineer out of university in my local city's water and sewer department, and spent many years in various parts of the organisation, both asset planning and operations section. I loved the job. It was really varied, and it felt great working to provide high quality services to the community that I grew up in. A few years ago, I was approached by the founders of Vapor to join them to look at how technology could be used to improve pipe condition assessments and also the decision-making process for engineers exactly like myself. It didn't take too much convincing to make the move, as I'd had quite a few frustrations dealing with CCTV pipe footage and plenty of ideas. So this one is not a stock photo. It's a very large sinkhole that formed while I was working as a city engineer. Probably one of the most challenging weeks of my life, as we managed 24-hour continual flows and a difficult repair of this major sewer carrier main. So could AI and automation have helped prevent or at least reduce the likelihood of something like this happening? I certainly think so, and hopefully we'll take a look at how this might happen. Another question that's sometimes asked is AI likely to take lots of jobs away in the engineering sector? So from my perspective, it's pretty unlikely, at least in the short to medium term. What we see it doing is removing some of the mundane and repetitive tasks that engineers dislike, as well as being excellent at drawing insights from large data sets. So in the past, engineers have often felt like they didn't have enough data to understand their assets, networks, and the processes that they were tasked with managing. What we've seen is a rapid development in hardware, capability, and communication options to bring data back in from the field faster than ever. We now have access to so much data that it's easy to suffer from data overload. Artificial intelligence can assist with its capability of rapidly processing large amounts of data, help make decisions, and provide advice. So you'll recognize the commonly used database symbol on the right. The icon on the left probably looks very familiar, or you may know what it is. So ChatGPT is probably one of the most frequently discussed AI models in the world today. It's an AI language model developed by OpenAI and launched to the public in November last year. I thought it might be interesting to query ChatGPT on the topic of the webinar to hear the response. Can AI and automation bring insights, efficiencies, and better decision-making to the water and wastewater industry? A dot point summary of the output is on the right, and I thought we could take a look into a few actual examples in the areas that is identified. So a real-world example of data analysis and predictive modelling is having sensors installed in a pump control cabinet to capture, process, and relay detailed performance data. The example sensor here is one of the ones from the Dutch company Semotics, who work across a range of industries to improve predictive maintenance and reduce unplanned downtime across a range of assets. Products like this look to build real-time pump curves, notify a failure, detect anomalies to auto-adjust pump control, and flag the presence of leading indicators of early signs of pump failure. The hardware to detect leaks in water networks through acoustic signatures has been around for many years, as has telemetry alarms that monitor sewer levels. But what has evolved in recent years is a reduction in the amount of time and resources required between an event occurring and turning it into a triage job that can be prioritized against other work. The interactivity between different systems using cloud-based data storage, APIs, and defined workflow rules means organizations can now begin to create automated workflows that get crews out rapidly to the problems that need fixing first. The manual generation of paperwork and work orders is reduced, and opportunities for better results, including improved levels of service, environmental impact, and cost. Artificial intelligence is being used to help refine and optimize digital twins of networks. This also includes the fine-tuning of water and wastewater treatment plants. Automation and AI is now able to help assist in the design of treatment plants as well. So this example is from a US company called Transcend, who are able to take process requirement inputs, including influent flow parameters, preferred treatment methods, existing processes, site footprint, and more to generate design documentation for wastewater treatment plant upgrades. This image shows one of the interactive screens where users can mark out the inflow and outflow points, areas where there are existing assets, and the land where there may be no build zones or preferred locations for future build areas. Sorry for the grainy quality of this one here. I've just compressed it into a GIF for this presentation. The output from this type of design generator is a document package that includes a wide range of concept design materials, from process schemes and piping and instrumentation diagrams through to BIM models and AI rendering of the design, like we see on this slide. So my area of expertise isn't in process engineering. I've spent much more time managing network assets such as water distribution networks and sewer collection systems. So I'd like to go into some more detail on the asset management of gravity sewer assets and how I see AI fitting into this space at the moment. So managing pipes that are in poor condition has often been split into two discrete components, often completed by segregated teams. The collection of CCTV footage and calculation of condition grade, and then making a decision and scheduling the maintenance or the rehabilitation of pipes. A common barrier that we've experienced and seen is moving efficiently from this initial pipe inspection stage through to the action on the ground stage. The purpose of inspecting pipes isn't to get a condition grade in a report or watch a video. The purpose is to drive sensible asset management decisions on what to do with at-risk pipes and allocate budgets in an optimal way. So AI can also help engineers with this task. Vapor's cloud-based platform is designed to extract information directly from the video and pull data, images, and engineering logic together onto a single browser screen. It's designed so an engineer can view the condition of their pipe, make a decision, and prepare work packages using a fast, accurate, and more consistent approach. It removes the requirement to sit through all of the long inspection videos before being able to reach a decision, and it focuses a person's time on the engineering tasks that really matter. So when speaking to people about artificial intelligence, there's often some curiosity about what's taking place in the actual AI model. It's not intended to be a black box or some secret process. We only need the video file itself to produce our results, and there's no need for the inspection to have any defects coded during the inspection. So let's take a look. Upon upload, each video file is automatically split into a series of still frames. The AI analyzes each of these frames, and based on over 100,000 machine learning training images, it checks each frame for the presence of a pipe defect and then categorizes these results to align with regional scoring standards. So if we take a single extracted image as an example, it will be processed in the primary AI model that determines if a defect is present and then what category of defect it might be. The image will be passed to one of many different defect submodels, in this case, the root submodel, which is tasked with classifying root type and magnitude. The output of the processing will be an image with the label and relevant defect scoring applied. This same process happens for each and every frame, with the end result being all relevant images from the inspection presented, scored, and highlighted for the user. From this point, the AI output can go through a quality analysis review by the user where any adjustments required can be made by hiding frames or selecting a defect change from a drop-down menu. Once an inspection is reviewed, there will be some automated logic run immediately in the background to provide a repair recommendation to the user. This recommendation appears on the right-hand panel, and depending on the type and the number of defects, a variety of maintenance or repair recommendations will show. The user can review the pipe condition and agree with or adjust the decision on what course of action is appropriate for the asset. In this example, we have a sewer pipe where the automated repair recommendation is to install a patch about 8 meters in. So users can toggle specific defect images to simulate what the effect of installing a patch at this location would have on the structural grade of the pipe. If you note at the top of the screen, for this particular pipe, it would reduce the structural grade to 2. This combination of artificial intelligence and automation is intended to drive optimal decision-making at an individual pipe level. It then flows directly onto a targeted program of maintenance and capital works. It only takes a minute to go from the repair recommendations export from the previous slide to this repair planning scenario for every single pipe in the system that has been reviewed with a decision allocated. This example shows aggregated decisions totaling around 4 kilometres of lining work and 14 patches across 13 pipe assets for an upcoming work package. Costing can be inserted into the repair planning based on the current schedule of rates if you have a civil works contractor or a panel, or you could use your last project's pricing or make some calls to arrive at an indicative budget estimate. While we don't have time to go too deep into thematic mapping of results, these results from Vapor can be integrated into a utilities GIS platform. So the layer here shows which pipes have been inspected with information including date of last inspection and condition grades. Hyperlinks allow videos and inspection reports to be opened with a mouse click. The video is able to pop up in a browser window and play directly from the cloud storage location. Other useful data that can be shared between Vapor and an organisation's GIS is a point layer with the defects from every inspection and their location along the pipe. So the world of pipes and pipe inspections also produces some pretty unique and weird situations. During our AI processing, we also come across all sorts of wild images. So we post on LinkedIn every Monday morning with examples of the strange and the weird that we find in pipes, and it's a light-hearted way to start each week. So from here, I'll pass over to Alakia, who is well qualified to take us even further into AI and how it fits into the sphere of engineering.
Thank you, Mark. That was a great introduction, and I am going to share my screen. All right. Let's jump right in and talk about the different types of AI and some of its practical application in the various fields of engineering. And towards the end, we'll also talk about a core concept in AI and machine learning. Right. Okay. So today, in general, most of the AI designs that we encounter pretty much can be categorized into these 5 main categories of AI. And this journey of AI, it starts from left to the right. There is 3 core types of AI here. And I've also got 2 futuristic states of AI, which we're going to see in the following slides. First of all, the first category of AI is called the narrow AI models. Now, this is otherwise known as weak AI. And as the name suggests, these models, they are designed to solve a very specific use case. And the knowledge of this model is pretty much within the data that these models are trained on. So they lack knowledge, pretty much anything outside of its learning space. Relatively, when compared to the rest of the types of AI models, these narrow AI models, they require less volume of data, and they can only evolve within that scope of that data. So they are pretty much applied in many use cases across various fields of engineering. And even for us, when we see or interact with a lot of AI models, there is a high chance that it's usually a narrow AI model. It's just everywhere today, from search engines to recommendation systems to movie, music recommendation, or even in voice recognition, video recognition, image recognition, and so forth. And in the field of engineering, they are predominantly used for predictive maintenance. These models are really good in analyzing the streaming data from sensors, and it can understand the underlying trend or pattern that's present in the data, which we can then use to understand the failure mode of a machine or of a process. These models are also used in quality control and inspections, from like detecting a defect on a product that's manufactured in a unit to understanding defect that's present in a pipe. And they're also employed in process optimization, resource management, traffic management, and so forth. The next type of AI models, they're called the foundational AI models. Now, they're otherwise known as large-scale AI systems. When compared to the rest of the AI categories here, these type of model, they need massive amount of data. And the idea behind these model is that in order to provide an elaborate knowledge as generalized knowledge to AI models, these models are designed to have a wide range of knowledge by collecting large amount of data, just about anything, and train the models on this amount of data to basically give the model ability to adapt to a wide range of downstream tasks. So in general, these models are meant to enhance the performance of models like narrow AI. So today, we use foundational AI models as a baseline, and we are building narrow AI models on top of foundational AI models. One great example of this model is ChatGPT. ChatGPT is built on a foundational AI architecture called GPT 3.5. Today, it's GPT-4. And they need massive, and this ChatGPT was trained on massive amount of data, which was roughly around 1.7 trillion volume of data points, which will roughly take about 22 years for a human to read all the data in that data set for about 8 hours every single day at an average reading speed. So as that sounds, they just need massive volume of data, not just data, it needs massive computing power. It's just so intensive on a large scale of resources. So it's not feasible to train this model on a day-to-day system like what we use for our day-to-day work. They need special machines and supporting systems to train and maintain these models. Moving on to the next type of model, they are the generative AI models. Now, as the name suggests, these models will generate content. And the content can be of anything. It can be a text, it can be a video, an image, speech, code, just about anything, right? So these models are built on top of foundational AI models. So they're also narrow AI models in a way, but just because they generate content, they have got their own category in this chain of categories here. And we have seen a lot of generative AI models becoming really useful for us these days. And I've got some examples over here. ChatGPT, they can generate text. Midjourney is a generative AI model, and it can create images based on a prompt that you provide. MuseNet is again an excellent generative AI models. They can create music, and we also have Codex by OpenAI, which create code. So these are all some examples of generative AI models, but we have plenty of generative AI models launching every single day. Moving on to the next type, we have the general AI. And this category of models are otherwise known as artificial general intelligence. Now, this refers to a system where the AI is able to perform similar to what a human can do. Obviously, this is very theoretical at this stage. We don't have any practical application, but the current development in the field of AI, it's just not practically possible to create a general AI model, but there are a lot of active research that's happening in this field here to take the capabilities of AI to the next stage. Before we move on to the next slide, let's just take a moment to appreciate this image over here, which is created by a generative AI model, Midjourney, based on a prompt. These models can be very creative. Moving on, we have the last category of AI models. They're called the super AI. This is a futuristic state of AI. This refers to a state where the AI systems are able to outperform or outscale human capabilities. Obviously, we are nowhere close to do something like this. This is mostly just theoretical right now, but look at the image over here. It's created by a generative AI model based on a prompt. It's just so fascinating. All right, enough about the different categories of AI. We're going to talk about a core concept in machine learning. Machine learning can be pretty complex. It is a very complex phenomenon trying to solve a very basic problem. So what we're going to do in the following slides is that we're going to try and understand what will happen when a machine tries to learn something. That could be a data. How can the machine try and learn the trend or pattern that's present in the data? We're going to try and visualize how that happens. And it's a very fascinating concept, to be honest. All right. The question that we have to ask is, what differentiates a machine and an AI system? The AI system is capable of processing data in a high dimensional space. And that is the differentiating factor between what humans can do and what AI machines can do. Now, all right, let's try to understand what is a high dimensional space. You can think about anything. You can think about people being in high dimension. Let's take an example. Let's take an engineer. Now, let's try to think about the different perspectives, like try to add so many perspectives to this specific engineer. You can start to think about the type of engineer he is, or you can think about what he studied, or you can think about his area of expertise, or where he studied and his experience, and so on. And all of this different information that we collect about this person is a dimension about this person. Now, these dimensions can become pretty complex if you try to think about different people, because people can be very similar in some ways, but can also be very different in other ways. And it can be very complex for a human to try and understand the similarities and dissimilarities by processing all this information, otherwise known as dimension, about different people. Now, this is the kind of thing machine learning is really useful for. With machine learning, it's really easy to basically process all these different dimensions about various people and map the similarities and dissimilarities between them. And the process is very simple. You don't really have to provide the meaning of these dimensions to a machine. Instead, what we do is we try to convert the dimensions into a numerical value, and then we pass this numerical value to a machine in the process of machine learning. And what this machine does next is really fascinating. It'll then try to map and process these different values that you've passed to a data entity. Now, this data point over here, it'll then be a representation of that engineer that we took in the previous slide as an example. He's going to be the data point from now on. The machine learning, in the process of machine learning, machines will then try to create all these different values as a set and assign that to the specific data point over here. And it will then place this data point in the high dimensional space along with the rest of the other data points. Now, every dot point over there, it represents a person, an engineer in our case here, with so many different dimensions, with several of those other information that we just collected, and it will try to map the data point of interest along with the rest of the data points. Now, when it does, what it'll do is it'll try to place this data point close to the points which are very similar to each other, who have like common information or common dimension, or try to scatter out the data points if they don't have any common dimensions between them. Now let's try to imagine, visualize how does it will work. Here is a great example. This is an example where a machine was trained on a small subset of words. Words was used as a data in this case, and the machine basically converted all those words into a data point. Every yellow dot that we see on this video here is a data point, and each data point has about 200 dimensions. So in this process of processing this information in high dimension, machines will just place similar points together and scatter out less similar points. This is the capability of the machine learning models or the AI system, which is gonna be very helpful for us to build systems on top of. Why is that? It's because we have not told the meaning of any of these dimensions to the system, but the system is now able to understand the relationship between each of these different data points. It is able to tell us the pattern or a trend that's present in this, the series of data that's been presented to the system. And this code knowledge is going to be extremely helpful in the downstream process. Now, a great example for this, again, is ChatGPT. ChatGPT is built on a foundational model, and the foundational model was trained on a large volume of data. When the machine was trained on the massive set of data, the machine basically was just processing all that data in high dimension and created a knowledge base just like this. And it basically came up with a relationship among the data that's present in that data set and used that knowledge base as a foundational knowledge to predict or to complete word sequence from a given prompt, which is very fascinating. Now, can it only work with the word data? Should be the next question, and the answer is no. The same principle can be applied to various types of data. There are other types too. Image is a different type of data. Now, the machines can still understand an image by doing the exact same principle. Now, let's take a data set, for example. The one that we see here is a very popular data set in the field of deep learning and computer vision. It's called an MNIST data set, where various people were asked to write digits between 0 to 9. And people write in all different ways. Now, the question is, should us, human, sit and manually code all the different ways people write, or should we ask a machine to figure it out itself and come back to us with a list of all the trends or patterns that present in this data, which will represent the ways people write? Now, the machines are capable of doing it. Now, how can a machine try to do it? It'll employ the same principle that we saw earlier. It'll process data in high dimension. Now, in order for the machine to do it, what we need is an image that represents these handwritten units. Every image can basically be broken down into a smaller chunk or a smaller unit called a pixel. Now, the example that we see in this video here, it's a digit 9, and it is an image of digit 9, and this image is about 748 pixels. Every pixel can then be considered as a dimension. Now, the machine will then take all this dimension, map that to a data point, and place that data point in a high dimensional space and see how that correlates with the rest of the other data points that's present in this given data set. Now, in this video over here, we basically color-coded the different data points, so it's easy for us to see what is happening when a machine tries to learn about the data. Now, we can see that the data set is evolving, the learning space is evolving. In this video, this is exactly how the machine will try to learn about this data that's present in that data set. And towards the end of this process, what it'll do is it'll try to cluster the data points that are similar to each other. All of the data points of the digit 5 will be clustered together, 6 will be clustered together, but these clusters will be placed far away from each other, meaning it is not related. This data point does not belong to 5, it will place it in the right bucket. Now, this underlying capability will help us to do a lot of downstream tasks like understanding about a given image, identifying a defect, classifying a given image, and so forth. And this specific phenomenon is what we use here at VAPAR to build our image classification model and object detection model to detect defects inside a sewer pipe. Everything is just so fascinating purely because the machines, even at this stage, does not really know what exactly it is processing. It is just working with a bunch of integers at this point. That's probably the end of my presentation today. But if you have any questions, please feel free to post that in the chat here. We'll come back to that at the later end of the presentation. With that, I'm going to pass on to Katie to talk about a very interesting topic.
Thank you so much. And hi, everyone. Thank you for having me. Thank you for the invitation. And Peter, thank you very much for the introduction. I am just going to get my slides up. Okay, so hopefully everyone can see those. Let me know if there's any problems. So I'm Katie Bevan, Programme Delivery Manager. So I work for United Utilities. United Utilities is one of 11 water and sewerage companies in the UK. We are one of the largest. My role, I cover all the routine maintenance of our wastewater network assets, essentially. So that maintenance is carried out by our partner contractors, but managed by myself and my team. The biggest program of which we have is what we call SSP, which is sewer serviceability, and that is kind of the cleansing and CCTV of our sewerage network. And that's kind of what I'm mainly going to be focusing on today, and that obviously links directly with our partnership with Vapor as well. Okay, so why do we need sewer network monitoring? So as I've said, we're one of the largest UK water companies. From a sewerage and wastewater point of view, we have 78,000 kilometres of sewerage network and 7 million customers that are affected. You can see there a little bit of a map in case anyone's interested in the geography of the area that we cover, if you're familiar with the UK. So we cover all the way up to Carlisle, which is kind of the Lake District, etc., and all the way down to Crewe, which is in Cheshire. So we have 6 drainage areas that fall within that you can see split up between those different colours there. So unfortunately, we have blockage and collapses each year, which then again, unfortunately, lead to flooding and pollution events. We are heavily regulated in the UK, and our regulators Ofwat require improved performance year on year, AMP on AMP. What we discovered is that over a 5-year period, we think 30% of the blockages that we're finding are actually repeat blockages, and we believe that better sewer network monitoring can prevent that. Okay, so on my cleansing and CCTV programme, we inspect 33,000 pipes each year. What fundamentally happens is that everything gets kind of what we call fast passed, so CCTV'd, and then my team make a decision on if we need to progress to an actual clean. So then about 20,000 of those pipes then progress to a clean each year. I don't expect you to be able to kind of see any of that there in terms of that process in the middle. But it just highlights to you that historically our monitoring process was very complicated. There was lots of people involved, there was lots of steps, there were lots of hurdles where things could go wrong, from on-site, the work being carried out, to actually understanding what the problem is within the pipe, what the defect is, and how we remedy that. Some of the challenges are...
Katie,
yeah.
Very sorry to interrupt, but there's been, I think, 3 or 4 people just sharing that they're not able to see the presentation. I can see from my side.
Oh, interesting. Okay.
So I just want to double check it.
Have a look what we can do.
Perhaps just stop share, reshare. It may be at their end, but I just want to make sure there isn't a large amount that can't see. Sorry.
Yeah, no problem. Thanks for letting me know. Let me reshare.
Looks like it might have just been a couple. Yeah.
Okay, no problem. I'll reshare via my screen. Is that back for the majority?
Yeah, we're all back up.
Yeah.
Very sorry to interrupt you there.
Excellent. No problem at all. It's funny because you feel like you could be talking to yourself, so it's good to actually hear a human voice back, actually. Okay, so yeah, some of the challenges, we don't want people sat watching pipe inspection footage all day, of which some of my team were doing for a large majority of their day. Obviously, that seemed completely nutty to me when I started this role. Couldn't believe that we were in this place where this was still something that happened. And also, additionally, they couldn't really see some of the defects that well. Just apologies if there's a little bit of background noise, but I am on a wastewater treatment work, so there's a lot kind of going on around me, but I'll continue. Okay, so they couldn't see some of the defects, they weren't that visible. And also the process from on-site completion of the CCTV being carried out to actually understanding what we needed to do was sometimes taken up to 12 weeks. Obviously, depending on the risk there, that's way too long for us to wait and get that visual and define exactly how we can progress with that. And additionally, the inspection programme, I have a certain budget that I have to inspect all of my sewer pipes. We were actually exceeding that budget year on year. And so what ended up happening is that towards the end of the year, so usually the last quarter, the inspection program would sometimes just completely stop because we actually did not have the money to progress that. And if you can understand, there was no risk element to that. There was no review of, okay, what are the important pipes within that quarter? It was just a kind of cut-off period because we didn't have the money, which is absolutely not the way that we want to work things. Okay, so Innovation Lab. I don't know if anyone's heard about the Innovation Lab at United Utilities, but innovation is kind of core to who we are at United Utilities, part of our culture. What we do every year, and we have done for I think the past 6 or 7 years, is we have invited suppliers, so smaller suppliers, larger suppliers from every country across the world. There is no kind of categorization of who can apply and who can't. It could be absolutely anyone. If you've got an idea, apply. And if you get through, you can basically use our data, our people, our systems, our assets, whatever you like, as a bit of a test bed for that supplier to understand how they can get the best out of their tech or product. And obviously it's a two-way street, because then we're also getting the benefit of understanding and be kind of the first in line for that product and seeing how we can benefit from it ourselves. The ideas, as it says here, range dramatically. So we've had things like sniffer dogs for leak detection, which has come through, which has been a massive success for us on the water side. And then additionally, Vapor, which has come through, I think it was about 3 years ago, Vapor came through our innovation lab. And you can see here, Amanda mentions one of the CEOs from Vapor that, you know, the reason why she started the company was actually because she was one of these people following graduation who was sat watching CCTV pipe inspections and couldn't believe that that was the way that we were doing things. There must be another way, which then started the company. Vapor came through the Innovation Lab in 2018. Was a huge success for us at United Utilities, and we have progressed last year into a full contract with Vapor, which is we're really proud of, because it's the first of its kind in the UK of a contract with a water company relating to the usage of AI. So a huge success story for us. Just a note on that as well, I don't know if it's the same across the globe, but we sometimes find that suppliers struggle to get into the water companies, so it seems a bit like a closed door sometimes. You know, they struggle who to contact. It's such a big company, who do we go to kind of get in there? And so the Innovation Labs gives us that perfect opportunity for people to come in. So something that I really enjoy being part of each year. Okay, so how did we optimize the sewer network monitoring with Vapor? So again, I know you've seen some stills from Mark around what the actual system looks like. But obviously what the AI does for me is it categorizes the inspection footage. So historically, what used to happen was we had the fast pass element where we had a look at the sewer pipe, we cleansed, and then we did a structural survey after the cleanse. So the structural survey, the structural coding was actually carried out by one of my contractors, and that was all carried out on site. So if you can imagine, you know, there's so many different codes, so many different defect types, thousands, hundreds to select from. There's a lot of opinion there, lack of consistency, weather plays a part in that. Someone might be having a bad day. It was very difficult to kind of understand the accuracy levels that we were getting and that consistency. And obviously you can understand that consistency is key to make sure that we are correctly understanding our risk and managing that appropriately. So I need to ensure that the correct defects are being located in the correct locations, so that we can then ensure that the right remedial activity is selected for that specific defect to resolve that issue properly. So it's just talking around how easy the system is for us to use. You know, the mobilization is very quick. And from an output point of view, we can easily extract a PDF report that gives really good visuals of the defects, what they are, what the remedial solution is, and we can then give that to our relevant engineers in our teams, who can then put that forward for funding to get resolved. So again, don't expect to see all the detail on here, but that was the old historic approach that I showed earlier. And then this is the new approach, which is obviously much more streamlined, easy. Everyone understands what they need to do and when, and everything is a lot quicker. So we now get that investment decision in between 2 and 5 days. And you could see before that used to take us about 12 weeks. From a financial saving point of view, obviously very easy to put a product in place and get the buy-in when we are receiving a cost benefit from day one. So for me, the cost of utilising Vapor is cheaper than it was for me having that kind of contractor on-site manual coding. So every time we do a length, every time we cleanse, every time we put that through Vapor, we are saving money. So it's an absolute no-brainer for me. What I'm also finding is that my team, because they have better data and they're a bit more empowered with the visibility and data that they're getting, they're able to kind of be less risk averse and so progress less of our sewer lengths to be put through for cleansing. And so we used to send about 60% of our lengths over to clean. We are now sending closer to 40. So again, 20% less lengths are requiring to be cleaned each year. And that is based on risk. And so that enables me to actually be able to afford my program, which is obviously a massive plus. From a contract management point of view, as I said, contractors carry out my works. I don't have the ability to be everywhere at once, and neither do my team. I can't see every 1 million length, being completed. So the fact that I have now Vapor, which easily gives me dashboards that show me, okay, so this contractor, this specific individual who works at this contractor is continuously going too fast down that pipe length, which is then meaning that we can't get good insight onto the defects and that the AI can't work to its optimum potential. So we can then push that back to the contractor, say it's too fast, I'm not paying for it, as an example. Just loads of things like that, just from an individual point of view and an individual contractor point of view. I have much better visuals to be able to push back commercially, but just manage and challenge where appropriate. And as I said before, it gives that consistent investment decision making. And also we don't have to sit watching pipe inspection footage all day, unless we need to in specific examples. But generally we look more at stills that Vapor is providing, and Vapor removes the lengths of pipe that we do not need to look at. Okay, it's just some kind of basic graphs really. So it's just showing you that I can easily see for my whole network or on a drainage area basis, what is the asset health looking like in that area? Are we seeing a lot of lower grade defects, higher grade defects? What's the top kind of remedial recommendation that we're seeing? What's the top defect? And things like that. So just much better visibility of actually what's happening. And then that top graph in the top right hand corner. So you can see here that actually the first time that we're going to the fourth time that we're visiting that pipe, the structural and service grades are both going up. So that pipe is deteriorating. And it might be in that instance that going in and jetting and CCTVing this length is actually causing more harm than good. And it actually might be that we're making the pipe deteriorate more quickly. And so we could then say, right, we're not doing anything further on my program. Let's send that over for investment or do a bit of investigation. Last thing we want to do is obviously making anything worse. We want to mitigate the risk. And then the bottom left graph, you can see, okay, this sewer length, we've been 8 times and the service and structural grade is both very low at 1. Why is this even on the program? We can look at reducing the frequency, save some money, hopefully end up removing it completely from the program, and instead spend that money on lengths that actually do need to be on there, that we might need to increase the frequency on. From a performance management point of view for my team as well, you can see on that bottom right hand graph, I can see clearly each person in my team, are they sending a lot of lower grade structural and service grade lengths to be cleansed and things like that. And that would call me out to say, okay, are we being consistent across the team here? Is there more training required? Because it might be, again, we just need to be kind of more risk averse, less risk averse, and it allows me to kind of performance manage correctly and appropriately using that information. Okay, so in terms of people outcomes, AI is like another member of the team, and that's the way we have invested into it. We know this was not going to be an overnight kind of success story. We've been in there, 3 years working closely with Vapor. The more sewer lengths of ours we put through, the better the AI will work for us. So I think a lot of water companies are guilty of doing small trials here and there, which we absolutely are guilty of as well. But I kind of push really hard at my end to say we need to just go full throttle on this. Otherwise, we are not going to get the benefit that we want, or we will, but it will take years and years and years. So the accuracy has improved greatly. Something to point out that I think it was very much thought of as at first that AI would kind of take over, robots are kind of coming and there would be no need for humans in my team anymore. There would be no need for anyone to do anything with this work. That's absolutely not true. we always will need to kind of quality check and QA all of the images generated. But what we're seeing here is that time will start decreasing and decreasing and decreasing, the better that the accuracy and the AI gets to know our sewer lengths and our sewer network. So it'll become more kind of light touch as time goes on. As it says here, it takes time. You know, I've highlighted that this takes time, and we are fully invested for the future with our contract with VAPAR. From an engineer point of view, as I said previously, we used to watch the entire video to understand repair needs. We no longer to do that. We can look at images and frames, so it's time saving. So from my team's point of view, they are spending less time doing less value added tasks like sat watching hours of footage, and they're able to spend more time looking at, okay, what are the actual defects and what do we need to do about that, and packaging that work up for remedy. Okay, so how are we optimizing? So we have a program called Dynamic Network Management at UU. Again, lots of water companies will be doing similar things, different titles, but essentially that's the installation of lots of monitors within our sewer network. And so it's understanding now, how can we get working, VAPAR with DNM, looking at the monitor locations, looking at the AI. There's some locations that we really struggle with in terms of getting access to clean, traffic management permits, customers. Can we actually install sensors at those difficult inspection sites? And then can we also install sensors at high inspection frequency sites, so that it means that potentially we can visit less frequently and save a bit of money that way, but we know that there are eyes on that site if anything does happen. And yeah, can we repair the blockage root cause, which means that we potentially could then remove that length from the sewer cleansing program. Just a little bit around DNM, which I mentioned. So DNM, I think we're at a point where, 17.5 sensors were installed across the region. We're now about 19,000 sensors, I believe. In terms of our reactive call outs, so when there's an issue, there's 25% less on non-infrastructure and 10% less on infrastructure. So that's our sewer network assets. We're getting 10% less reactive call outs and issues because of these monitors being in place, and we're able to get eyes on the network all the time, live 24/7. We're also getting 37% less wastewater customer complaints, which is huge for us, and there's a lot more proactive issues that are being detected prior to an issue actually coming to a head. So 5,000 of those over the time that we've been working on the DNM project. What's next for us? So obviously looking at those capital programs of remedies, we've got all these repair recommendations. How do we package them up and either progress to resolution? Looking at, okay, so we're looking within the pipe now. How can we start looking at what's going on outside of the pipe? Looking at satellite imagery. Planetech Italia is just one company that offer that service, but there are other companies as well. So how do we look at what could be going on outside of the pipe in terms of geography, what things are moving around that could be, causing structural defects within the pipe, causing collapses and things like that before they happen, and looking at working with camera providers as well to see, okay, so can we look at putting the AI within the actual camera technology, getting to a place eventually where the camera will stop, slow down, things like that itself when it comes to a defect, instead of someone actually operating that, having to do that sort of task. All these sorts of things are kind of things that we're looking at and working through. And again, just putting all of those things together, DNM, satellite monitoring, VAPAR, and then also, what next is going to come through the innovation lab. That's applications have just closed for that, so we're intrigued as to what's going to come next and kind of how we can work with them. And those are all the kind of different optimization opportunities that overlap each other. So by summary, the definition of insanity is doing the same thing over and over and expecting different results. We're very aware of that. We know we needed to change, and we're really, excited about it, proud of the achievements that we've made so far with this partnership, and looking forward to what's next. The innovation lab was huge for us in providing us this system and this tech, which we feel gives us more efficient network management process. And we also know that the introduction of DNM, the monitors and other technologies will allow for that further optimization. And that is me. So thank you very much.
Well, thank you very much indeed for a really good presentation. So thank you to Mark for his extremely good introduction, and also to Alekia for the AI portion, explaining the background of the AI and the different parameters that you have, and also to Katie for giving us a really good in-depth view of how the technology is actually being used practically. So I think the main thing there is I took out of that was the fact that collecting the data is one thing, which is relatively easy, and I say relatively inverted commas, but then what do you do with all the data? And you've got to analyze it. And this goes across all sorts of aspects of, we can collect data, but the data itself isn't any good unless it's analyzed correctly. So I think this was a really good example of finding, we have technologies, but then finding a very, very practical use for those technologies. So thank you very much to all three of you. Thought it was excellent. We'll have a look at some of the chat on the chat box. Actually, let's see what's coming through here. I'm just going to go to the top. Okay, there was one from Michelle who says AI is great and there is room to use to improve and make our work efficient. Should we as professionals be worried that our jobs are no longer secure due to development and application of AI in our industry? I don't know if you would like to. That's a fairly broad question, so anyone can chip in there and go for it.
Yeah, it's a great question, and it's definitely one that we hear. And look, as an engineer myself, absolutely understand where people are coming from. And what I would say is AI moves fast, but it doesn't move so fast that people can't adjust as it hits the industry. So people that are already embedded in work, that work's always going to continue. We have, the US has an infrastructure gap that's over $2 trillion now. So it's the same in Australia, South Africa, Europe. There's this big gap in work that engineers need to do. What we need to do is become more efficient at how we do it, make the most of our time and the money. So I think the often quoted line that it's not AI that's going to take your job, but someone who knows how to use it, probably it's pretty applicable to engineers. So I think as long as you're aware of what's coming and adjust and follow the technology in the same way that we move from slide rules to computers to spreadsheets and to databases, the same thing will happen, maybe a little bit more compressed time frame as AI and automation comes through, but it's not going to remove the need for us to be there.
I'll also add to that, if okay. I get asked that question quite a lot by people within my industry, actually, and for me, specifically in my team, instead of meaning that we are now spending less time reviewing the footage, which people equate to, okay, you need less people, less headcount. That's always what people are trying to do, steal people off me. I've just been able to say, well, actually, no, because that to me wasn't a value-added task. I'm now able to fill that gap with much more value-added tasks. So as an example, my team didn't have a lot of time previously to actually review the kind of defects that we were locating on the back of our cleaning program. It was more kind of just like hand off to someone else to deal with. We didn't have the time to kind of look into it in detail. Now they are able to do that and they're empowered to do that. And it's actually making them, I think they just feel like they're adding more value as an individual as well. So everyone is kind of a lot more positive about being in work. They don't feel like kind of a bit of a data monkey. They're kind of doing really value added things and they can actually see the benefit of that. And I think speaking to other water companies, they've kind of gone with the view, oh, we've just got rid of loads of people because we're using AI now. And then when I actually challenge them on that, I think it has kind of made a bit of food for thought, really, in terms of actually it's that empowerment for the people that we have and making their job easier and getting more value out of them. That's the way I kind of took it, and it's working really well for us.
Okay, thank you very much. That's really interesting answers there. Okay, let's have a look through here. Another one here. How can we avoid making errors using AI? Is it similar to the software we use for analysis and design or programming, where garbage in, garbage out? So
yeah, Alakia can probably expand on my thoughts, but yeah, it's absolutely right. an AI model, if you put garbage in, you'll certainly get garbage out. I think an example would be the training image. I mean, speaking from where we work at Vapor with machine learning and computer vision, if you have the wrong training images, you know, the garbage in, you're gonna have a poorly performing model, and the results won't be so good. So how do you avoid it? I think generally speaking in AI, it shouldn't be a black box, right? Like whoever is trying to tell you this is a better way of doing things, or this is a new software, they should be able to explain in layman's or more simple engineering terms what's actually happening in the background, and give you that broad process as well as the limitations. So for example, we are able to monitor perhaps the defects that are less accurate or not performing as well as we want. And they're the ones where we can go back in and have a look at the training images to say, okay, maybe we need more of them. Maybe we need a broader range. Maybe we need to double check to make sure that they're the correct images in there to make sure there's less or no garbage in.
Yeah,
Yes.
I think I can probably add on to a couple of points over there too. So there's no 100% accurate AI systems available to us today, and they can never be an 100% accurate system. And this is the field where I think both us and the AI system has to work together to get the best out of it. And it sort of ties back to the previous question of how AI, it's just not possible to replace a human by a machine, because it's just a human. If he is able to explain the problem statement clearly, then he'll be the right person to build that model. It's all about the data. It's all about understanding the whole of that domain space. So touching back to some points which Katie has mentioned in our slides about quality control and quality check, it just needs to be there throughout this entire process of designing a system to building a system and monitoring a system. We need to closely monitor how is this data drifting from when the model was trained to what is available to us in real time. So there is a lot of touch points with these systems, and there is always, we just have to be always aware of the fact that these models are not 100% right. It's like a co-pilot, which is going to help us do our job.
Okay, thank you.
Can
Any
I
more
just
comments,
add a point
Katie?
on there? Yeah, for me, I think it's about being realistic as well. So I think there was an expectation from some in my company that, you know, AI is coming in, it's going to be 100% accurate. Being realistic about progress and what we're aiming for and what we had previously as well. So that's great. But actually, if you looked at it, were my contractors on site who were doing the manual coding giving me 100% accuracy every time? Absolutely not. You know, when you look into that, it might be that they were more like 70% accurate as an example. So it's about being realistic about what you're actually aiming for. You know, nothing is going to be perfect, especially initially. And that touch point, you know, we're always going to need a human to check the AI, as far as I can see, doing the work that I'm doing. And I don't think that's a bad thing. And I think it's just understanding and being realistic and open about that. But also understanding that it will be less over time. And you have, like I said, just got to go fully into it. As the more data, the better that you can put through. None of these kind of small trials here and there. It's just not going to work. You know, you need to kind of go full in, put all your sewer network in there, do it for a number of time over a number of months, so that the AI for my network can fully understand my network and the intricacies I have in my network. Because that's another point to make, is that, you know, all sewerage networks, as an example, are very different. We have challenges here that other people might not. We have a lot of brick sewers, as an example, things like that, different shape sewers, egg-shaped sewers. So I just think it's about being realistic for me, and not, there is some risk there that people are nervous about, especially for me, such a regulated environment. And so I think the message is there is human interaction, we are still checking it. But we are getting a much more consistent products now versus what we were getting previously. And so it's a look back about what you were getting before. I think that's very important.
Okay, thank you very much. That's really good answers there. Okay, just another here, more of a comment, which really goes to your mention of the fact weird things in pipes. Someone's here, Rowan has actually said, we even discovered a Toyota Hilux dashboard in a sewer in East London, South Africa. So there you go, it's your list, Mark.
Rowan, please tell me you've got a photo. Send it through. Look,
Yeah.
anyone that works, obviously the presentations were heavily focused on the water and wastewater sectors where we are, but anyone that's got interesting photos, please share them. We love seeing them.
Okay. We've got another question here from Magashore. I'm just going to scroll back up because it just disappeared. Okay. How room is there on the design side for allowing more room for the application of AI, whether in design or asset management? So who would like?
Yeah, I think there's definitely a lot of scope. It's always hard trying to predict where things are going to go. I haven't used, I mean, the Transcend software that I've shown. I have spoken to the people that work there, seen some presentations. Haven't used it myself, but things like that are really exciting and interactive. And I mean, from my side, it almost makes your work even more fun as well, which I think is good. From the design side, I think because artificial intelligence is so good at analyzing bulk data, things like optimizing space or material or understanding critical timeline or even logistics of where you're going to source your material, all of that becomes so much faster or instantaneous that it's able to assist. From the asset management side, look, I think in terms of scenario planning, whether it's risk-based or budget-based or load and capacity, being able to use that automation and assistance from the artificial intelligence just provides more, I guess, allows you to see more into the future when you're planning, whether it's your budgets or how you're going to expand your network. But yeah, I guess time will tell.
Thank you, Mark. Anyone else got any comments on that? No, we'll move on to the next one. This is from Shavir. Thank you very much for the presentations. Has there been any development and success with the application of AI in master planning of hydraulic systems, i.e. pipe network planning for metropolitan areas? How far off are we from realizing these benefits?
Again, good question. Not sure where they're exactly up to. I'm not involved directly in master planning. There is a company called Quatium, Q-A-T-I-U-M, and they have some really interesting models and graphics. So I'm keen to see where they take their product. But again, a really useful application for scenario planning and using a computer to take in a lot of data, throw out scenarios, and essentially allow the engineer there to adjust the levers to influence the output in a way that delivers the infrastructure, the service levels that they're looking for their community.
Okay, thanks, Mark. Any comments from anyone else? Okay. All right. We then and then Chris has chimed in as well and says he's even found a mattress in the pipe. So I'm just going to scroll back. I think we've covered all the ones coming in at the moment. I've just got a couple of questions. You mentioned, I think it was Katie mentioned that training the AI on the networks in the northwest there would probably be different from, say the southwest or the southeast or the north of England, etc. In what aspects would that be? In terms of the data, would it be different shapes of the sewer, the different materials, brick, and then would it be, like PVC or steel or things like that? What have you sort of found?
So I think generally there are quite a lot of differences, whether that be kind of pipe material, the shapes of sewers. Brick sewers are something that in the northwest we have quite a lot of, especially in our kind of city centre locations, Manchester city centre locations. We have really big diameter pipes made of brick. And I think with Vapor initially, that was a little bit of a challenge because, tell me if I'm wrong, guys, but I think in your kind of repertoire at that time, there wasn't a load of data probably on brick sewers. So that was something that we had to kind of learn from the start, really, essentially. So again, trying to put as much through as we could so that the AI could learn the kind of intricacies of brick sewers. I think for us, you know, the geography can be very different, which varies probably, yeah, dramatically across the kind of sewer network, really. You know, in areas of Cumbria, we have very long lengths between assets and things like that, you know, loads of fields, which has its own challenges in terms of access and things like that. Farmers, you know, just anything like that. But then we also have city centre locations from an access point of view that are really difficult because of high traffic areas, which again can cause issues in terms of sinkholes, deterioration, you know, pipe loading, things like that. So I'd say the main one for us is probably difference in terms of materials, which kind of can be different across the UK, but probably more when we were looking at kind of our sewer network versus Australia. I think brick sewers was specifically the one that was a little bit of a challenge because we were kind of starting from zero on that one.
Okay, all right, thank you. And also I've got a question maybe best for Alekia to answer, was with collecting the data, when you have all the data, have you found that you would ever get to a point of diminishing returns? In other words, you can get more and more, like more millions of data points or assets or whatever you got in there, and then have you ever found that, you know, putting more in there, more data, actually isn't helping to interpret that? Has anyone done any sort of studies on that? Or
Yeah, to start this journey of developing a variety of AI models, the trend was sometimes in the data-centric side where we use a lot of data, but then there are also some researches and activities which showed or proved results where when there are better model-centric approaches, the results could be, you know, even better, right? Now, this is a very subjective thing depending on the type of solution that you're building, and this data for the models that we use here at Vapor, the type of data that we use, it has a lot of subjectivity in it. So sometimes it's better for us to just get as much data as possible to sort of make sure that we cover all of that edge cases. So the model that we are training is able to understand each of these different variety of different, you know, representation of a certain defect or something that of interest. So the problem that we are solving right now is we are very data centric, so we collect as much data as possible. But there are other solutions, AI related designs, which are very model centric, and those are the areas where more the data is not going to be beneficial. You have to be very clear about the amount of data that you use, the boundary between the data and the model. It's such a thin line. And you can, you know, at some point, it's just an experimentation process that you have to do to understand where exactly you should draw the line and stuff like that. A very good example of this approach between the, you know, the model-centric and the data-centric approach is the development of ChatGPT. When ChatGPT was first launched, with its GPT 2.5, the model was so bad. Like it was there online, like it was just open sourced online, and I did not even try that model because the model was so bad because it was a model-centric model. It was not trained on a massive amount of data. And what has changed from GPT 2.5 to GPT-4 is the volume of data. So they've realized that in the space of natural language processing, the more the data is what is going to bring them a lot of benefit. So when it was trained on a massive volume of data, they've started to see and notice a lot of other, you know, positive outcomes from that. And there's obviously other model-centric approaches that they made, but the realization was very crucial that they needed a lot of data. So yeah, there is a bit of an experimentation, and it's very subjective to the type of problem that we are solving. And so there is no generalized concept to, you know, how the volume of data that we should be using for training a model.
okay, thank you for that. Yes, I see we have a few more questions still coming in. Just scroll up a little bit. This is from Chris. Saying thanks from my side for to the presenters. Your efforts are much appreciated. Do we have any AI solutions in the geometric design space for railway lines? Well, that's an interesting topic. I mean, just does sort of throw it out there, you know, like, you know, is there no limit, in other words?
Yeah, this is a very interesting question, is because I remember reading a paper recently just on the same topic about creating an AI, solution for a geometric design in railway lines. We don't have a lot of prototypes or working models, but what we have is a couple of research papers with a bunch of ideas about how this can be implemented. So the answer is no, we don't have them working. So if Chris, you've got any great idea in that space, I think it's the right time for you to just jump on it and do it. It's a great time.
Okay, thank you for that. And there's a question here from Devek. Might be ambitious, but are there currently any 3D scanning applications being applied to pipe inspections?
Yeah, so we've had a look. We've certainly tested it out. I've dropped an image in there which people should be able to see in the chat. So we've run drones into pipes with LiDAR attached. So LiDAR is now available so small that a drone is able to carry it. There are plenty of challenges putting drones underground, staging communication being the main one, but the other two are backsplash from water. They generate a lot of downwind, which makes them hard to control even with the anti-slam technology. The other is battery life. The LiDAR and the lighting becomes quite heavy, so the runs that you can do aren't quite so long. But we can't develop this new technology without testing it, and things only become lighter and faster and better. So these point clouds are really, really cool.
Okay, thanks, Mark. We've got another question here. Is the VAPAR software designed specifically for major asset management projects, such as for large municipalities and deep integration, or can it be applied on an ad hoc basis to do condition assessments for smaller brownfield projects?
Yeah, absolutely. It's designed to go from pretty much the smallest to the largest. So Katie's obviously with United Utilities, which is a very large customer, because the UK only has a dozen or so across the whole covering the whole country. Australia's a lot different, perhaps a little bit more like South Africa with smaller councils and cities, all the way down to private projects. So we can do brownfield projects, greenfield projects, so acceptance testing of new development sites, and even pushrod cameras in house service lines and laterals. So yeah, I mean, Charlie, if you're interested and got footage and want to know more, you're more than welcome to get in touch. We can definitely process some example files, and I'd be keen to have a look at some footage from South Africa as well.
Just to add on to that, even though kind of as a whole we utilize VAPAR on kind of a large asset base on kind of a large program of works, we also do ad hoc bits of work here and there as well. So smaller meterage, smaller diameter. As Mark said, we've done some work using the pushrod cameras and the utilization of VAPAR and the AI on that as well. So absolutely, I think it can be used for anything. Small, large, kind of whatever it is. I think the consistency is key and it's there. So yeah.
Okay, thank you for that. Okay, we can see your image, Mark, so thanks for putting that in the chat. Okay, I can't see any more questions at the moment, so I think what we'll do is we'll wrap up the session for today. So I'd like to thank very much to Katie, Alekia and Mark for their excellent presentations that they've just given us today, and also to acknowledge, in fact, the time and effort spent in preparing such a presentation. We do understand that, and we are very grateful, and therefore SAICE IT Division greatly appreciates this. So thank you very much to all three of you. I'd also like to thank Debbie for the back arrangements, the back room, as it were, and for organisation of the webinar. And also to our attendees, lastly, if you'd like to join the SAICE IT Division and the sister committee, you can contact me or Debbie via SAICE, and we'd be very happy to connect with you. So with that, I'd like to say again, thank you very much indeed for everyone for attending, because without the attendees, we wouldn't be able to run these webinars and being able to show you new technologies from around the world. So with that, I wish you all a very good rest of the day, or good night, or good morning, depending on where you are in the globe. And thank you very much, and I hope to see you all again soon.